Here's another example of a work problem. This one involves lifting something up. So let's read it. Helen lifts a 5-kilogram box from the floor to a shelf with a height of 2 meters. How much work did she do? How much work did the earth do? So two questions involved, right? How much work did she do? How much work did the earth do? So we got two pieces of information, 5 kilograms, 2 meters. So we're going to write that down. Mass of the box is 5 kilograms. And the height, or the delta x or the delta y, whatever you want to call it, you can call it h delta y, is 2 meters. Now let's draw a sketch of the situation just to get a handle on what's going on. Make sure we visualize it. Here's the box. Here's Helen in the initial state. She's bending down to lift up the box, bending her legs. That's good form. And then afterwards, this is the final state. The box has been lifted up and has a height here of 2 meters. Take note of that. All right, now if we're going to find the work, remember work is force times displacement. Notice that I need to know the force. And when I look at the information that's given to me, I don't have the force. So what I'm going to do is I'm going to create a force diagram of the box. And let's see if this is going to help us to find what the force of Helen is. Helen's lifting up, and Earth is pulling down on this box. And if Helen's lifting the box up and then placing it somewhere, her average force is going to be the same as the force of the Earth if she's lifting it slowly. It doesn't say anything here about the acceleration of the box, so we're going to assume that the net force in the box, overall average, as Helen's lifting it, is 0. Now that's helpful because even though I don't know the force of Helen yet, I can find the force of the Earth. Right? We know that the force of the Earth is mg, the mass times the acceleration due to gravity. The mass of the box is 5 kilograms. And we round the acceleration due to gravity to 10 meters per second squared. So the force of the Earth is 50 newtons. That means the force of Helen is also 50 newtons. Oops. All right, now that's helpful. Now I can take this equation and solve it. So for Helen, the work is going to be the force of Helen times the displacement of the box. The force of Helen is 50 newtons up, so I can leave it positive, and then delta x is 2 meters. So she does 100 joules of work on the box. Now the Earth, on the other hand, because the Earth is pulling down, the work is going to be negative 50 newtons times 2 meters. So the work done by the Earth is negative 100 joules. Now I get that from the signs of the multiplication here. Negative times a positive number gives me negative. But also I could have told you at the beginning that the work done by the Earth would be negative because the force of the Earth is down, but the displacement is up. And so since the force and displacement are in opposite directions, we get a negative work done by the Earth, which seems a little bit strange. But what that really means is simply that if the Earth is outside the system, it's taking energy away from the system. So if we were just looking at the box, if the Earth wasn't there, then the box would result with something like kinetic energy moving up and away from Helen.